So we have some basic graph transformations, and we're going to talk about them in terms of square root graphs. So I have three different letters in here, A, C, and D, that are going to represent three of the basic graph transformations that we can do. And the A value always is going to sit in front of the square root graph, the square root symbol here. So what A does, that's called our vertical stretch or shrink. So it's going to either stretch the graph, make it taller, or shrink the graph, make it smaller, based on the value of A. And one special thing to take note of is that if the A value is negative, if there's a negative number in front of that square root symbol, we call that a reflection. So it's also going to flip the graph upside down. Now when you move inside the square root here, right, x minus c, so x minus a number, that value c moves the graph either left or right depending on its sign. So we have two options. It can move right or left. So if it looks like x minus c, that's going to move the graph right. If it looks like x plus c on the inside of the square root, that's going to move it to the left. It's always going to move opposite of the way it appears. And the last transformation we're going to talk about is moving the graph up or down. And that's going to happen with this plus d value that is typically written at the end of the equation. So it's going to be moving up if you have a plus sign with that value. And if you're subtracting a number on the end, it's going to move the graph down. So we're going to practice that and kind of talk about the starting point as well. So the original starting point of a square root graph is always the origin, the point 0, 0. And this point is going to change. The starting point will change for a graph based on any left or right movements and up or down. So you just want to move the origin to the same position that the graph tells you to based on moving right or left and then up and down. And let's go through some examples. So we're going to list the transformations and starting point for these two equations. So the first equation, y equals 2 times the square root of x minus 3 all minus 1. So our A value here is 2. So since we're multiplying by 2, and when we multiply by 2 something gets bigger, we're going to say that we have a vertical stretch of 2. In other words, the graph is going to be twice as tall as the original square root graph. Inside our square root, we see x minus 3. This is like our C value. And since it looks like x minus the number, that means our graph is moving to the right. So our graph moves to the right 3. And at the end of the equation, we have minus 1. That's like our D value. And since we have minus a number on the end, that's going to tell us to move the graph down 1. So there are our transformations. And then we're going to take our starting point. So originally, the basic square root graph, y equals the square root of x, would have started at the point 0, 0. So we're going to think about using our right and down transformations to find the new point. So if I want to go to the right 3 on the x-axis, I'm going to add 3. That means my x-coordinate's going to be 3. And then I'm going to move the graph down 1. And I'm going to have my y-coordinate be at negative 1. So my starting point of this graph is 3, negative 1. Let's try another one, and we're going to put a little bit more into this graph. So our second example here is y equals negative 1/4 square root of x plus 6, all plus 7 on the end. So since we have a negative here, that means that we are reflecting the graph. So we're going to say we have a reflection. Our graph is going to be flipped upside down. And then this 1/4 value is like our A value. So that tells us whether we're stretching or shrinking. So if we multiply something by 1/4, the value of it gets smaller. So because the value would get smaller, we're going to say that this is a vertical shrink of 1/4. Another word you can use instead of shrink is compression. Then inside our square root, we have x plus 6, and that's acting as our C value. So because it says x plus a number, it's always going to be opposite with the x motion. So we're actually going to go to the left 6. And then at the end, we have a plus 7, which means that we're going to go up 7. So the only transformations that affect the starting point are moving to the left or right or up or down. So again, we're going to think about starting at the origin 0, 0. If I start at the origin and go left 6, I land at -6 on the x-axis. And then if I go up 7, I land at +7 for the y-coordinate. So my starting point here is going to be -6, 7.